Hi everybody, happy Thursday. Today we are talking about graphing in science. So usually in our wheel of inquiry, this is actually after we've finished gathering all of our data, and we kind of want to see what it means. So what are graphs used for? In science, graphs are used to analyze our data. So what they do is they help us understand and recognize trends and patterns more easily. Sometimes we can kind of recognize that when our data is just in the data table. So if there's not a lot of data, a lot of times you can just look at the data table and be like, oh, that number is really high, or oh, that one's really low compared to the rest. But when you have a large amount of data, it can be difficult to make those realizations or recognize those things just in a data table. So they help us make sense of a larger set of data. In this class, the two common types of graphs that we use are bar graphs and line graphs. Sometimes we use like a pie chart or a circle graph, but not a lot. So that's what we're looking at today. Bar graphs look like this. I'm sorry, that one's kind of cut off a little bit, but what bar graphs are usually used for is to compare things of different groups. So you can see here it says, what kind of pet do you own? This is more of like a survey, and it's showing the different types of pets and counting how many people have each of those types of pets. Same thing over here. We've got types of seed and the different number of species. So we're comparing items between different groups. Line graphs are usually used to track changes over different periods of time. So you're looking at how something changes over time. Sometimes it can be tricky whether or not to use a line graph or a bar graph. But again, usually when you're looking at something and how it's progressing over time or how it's changing over time, we would like to use a line graph. Just a couple of basics on what your graph should include. All graphs that you create or are looking at should have an informative title, labeled axes, so x-axis and y-axis. You should have a graph that uses majority of the graph space, which we'll talk about, and obviously your data should be put inside of the graph. So basics of creating a graph. We're going to pretend like this is our question that we have gathered data on and we investigated, and now we're going to take our data from this question and we're going to and create a graph. So let's say we investigated, does the type of fertilizer affect the number of seeds a pumpkin has? So let's say we did an experiment where we are pumpkin farmers and we want to make sure that the pumpkins that we create have a lot of seeds in them, because you can like harvest the seeds and eat them. If you've never had pumpkin seeds, they're actually not that bad. They're pretty good if you like roast them and put some salt on them. Anyways, let's say our goal is to create pumpkins with a lot of seeds. Okay, so we're using different types of fertilizer to get as many seeds as we can. Let's say we do the experiment and we get this for our data. We've got 4 different types of fertilizer, A, B, C, and D, and we've got our number of seeds, 100, 280, 270, and 400. So obviously, looking at our data table, we can kind of see some trends and patterns because we don't have a ton of data. But again, if we had a larger set of data, it might be difficult to see those just trends and patterns. So let's say we wanted to make a graph of this. How I make sure that I have all of the different parts that a graph needs is I use this method called the house method. So think of building a house. If you're a builder of a house, there's certain steps that you kind of have to take in a certain order to make sure that your house is all set and looking good, right? Same thing goes with a graph. In order to ensure that you have everything on your graph that's needed, it's best to go kind of in order of following these certain steps. So that's what we're going to do. So first step in creating a graph is to label your x-axis. That's kind of like laying the foundation of your graph or laying the foundation of a house. You're not going to start building a roof on a house if you don't have the like ground floor created, right? So if I'm testing how different types of fertilizer affect the number of pumpkin seeds, I would put fertilizer down here on my x-axis, and then I would label type of fertilizer, and I would label each of those different types that we used. Second step is to add a y-axis label and create a scale. Now, I'd say this is probably one of the toughest parts of creating a graph. I know when I was in school, I could never figure out a good scale to use. And we're going to talk about that in a second. We think of adding a y-axis, which again, this is x and this is y. We think about adding a y-axis like building the walls of a house. You can't put a roof on a house. You can't decorate a house. You can't really do anything until you've got those walls up after the foundation has been laid or the floor has been laid. So that's the second thing that you do. Now, again, like I said, deciding a scale, I think, is the most difficult part. Usually what I first do is I find my highest number in my data set, okay? In this graph here, the highest number was 12. So somewhere up towards the top, you should have 12 or a little bit over. So sometimes it's best to just start going up by ones. And then if it doesn't work, if you can't get to the, like in this case, 12-ish, then you probably have to go up by my 2s or by 5s. One common thing I see with kids is they start going up by 1s and then they realize that, oh shoot, it's not going to work. And then they start adding lines to the graph and adding like rows. You can't do that. So finding an appropriate scale, start by going up by 1s. If that doesn't work, go up by 2s, then maybe 5s, 10s, 20s, until, again, that highest data set point should be somewhere towards the top of your graph. And again, sometimes it just takes a little bit of trial and error. You start going up by one number and, oh, that doesn't work, and then you erase. Try going up by another one. The key, I would say, is to use as much of the graph space as possible. You do not want a little baby graph way down here at the bottom. You want to use as much of the graph space as possible. So we've got our type of fertilizer here. We've got our number of pumpkin seeds here. And again, if I look back here, my highest number was 400. So again, that's how I decided to go up by 80s in this case. Again, it took me a little bit to figure that out. But again, I've got my highest data point up here, and I've got a consistent scale, meaning I'm going up by 80 every other line in this case, or going up by 40s with every single line there. So next thing is informative title. This is kind of like adding a roof to your house. So I'm not just writing pumpkin experiment or seed information or number of seeds. I'm writing, the best thing to do is to write your question that's informative. So does the type of fertilizer affect the number of seeds a pumpkin has? That's telling me exactly what information I'm going to find in the graph. Okay, so now I have all of these different parts. I've got my labels, I've got my scale, I've got my title at the top. The last thing that you do, you guys, is to put your data in. So decorate the inside of your house. Add your data to your graph. Again, you're not going to be moving in a lot of stuff. You're not going to be doing a lot of decorating in your house until you have the floor done, the walls done, and the roof done, right? Same thing goes with graphing. Don't start adding your data, you guys, until you've got all these other things set in place. So I've got my data, it's neat. I've got my bars, everything is spaced out. I'm using majority of the graph space. So it's looking good. So again, checklist. Is or do I have my x-axis labeled? Is my y-axis labeled? Do I have an appropriate scale that goes up consistently? Is it going up by 1s? Is it going up by 2s? Is it going up by 5s or 10s? And again, you look at your highest data point to kind of determine that. Did I use majority of the graph space? Is my graph just have like in a tiny little corner with little baby bars, or did I kind of spread it out? Is my title informative? Just use your question. Just take your question and put it right up at the top of the graph. Did I graph all my data correctly? And is my graph neat and can be interpreted easily? Those are kind of the questions that you should be asking yourself or double checking once you've created a graph. All right. If you've got questions, always feel free to let me know. Over the next couple of days, we're going to be interpreting some graphs and trying to understand, again, trends and patterns and relationships that graphs show us. Have a great day, everybody.
What, Mom? No, that's you, Mom, that smells, not me. Absolutely not. I am not taking a bath. No way. No, It's dinner time. I'm hungry. I'll only take one if Timmy takes one. Only if Timmy does. Timmy, I have to take a bath, which means you have to take one too. I can smell you from in there. Oh. Yeah, Timmy, you need a bath. Oh, gross.
I do not. I smell better than you do. Fine. Oh my gosh, what is this? Oh, okay. What, ooh.
What are you doing? Is that a toothbrush? Oh, so that's how you clean him. So you scrub his shell? Okay, alright.
It kind of tickles. Oh, it kind of tickles a little bit here. Well, oh gosh. What? Ooh, okay. Oh, was this a ball? I didn't know you could play with bath toys. What's this? Is this food? Oh, I'll play with this. I'm all warm. Rory, will you drive me off?
No, it's not my time yet. It's cold. Can you turn it up? Oh my gosh, Mom, turn it up. Okay. That's my butt. Okay, yep, you're done. Oh, Mom, not on the face. Fine. Ooh, scratch. Oh, I like scratches. Okay, alright. Yep, right in the bump. That's good. Okay. Alright, you're kind of being a little rough, Mom. Yeah, just rinse it off and be done. Come on. Yep, okay. Yep, this is terrible. How come Timmy got to do it in a tub? A relaxing bubble bath. Oh my gosh, this is where I get my revenge. Mom, I can't breathe. Mom, I can't breathe. I gotta kill this thing. We're not doing that again, Mom. Never again.